So learning target 3.3 has us explain the law of conservation of mass. Now the law of conservation of mass states that in a closed system, mass cannot be created nor destroyed. Or in other words, you could say the mass stays constant. So if you look in this specific example, we have a reaction between two things. One is CaCl2, and the other reactant is Na2SO4. Now, as the reaction progresses, products will be formed, and the products in this reaction are CaSO4 and NaCl. Now, once again, the law of conservation of mass states, as written above, mass cannot be created and it cannot be destroyed. It stays constant or does not change. And we should see that here. If you put the actual reaction on an electronic balance before the reaction occurs, the mass is 300.23 grams. And if you look at the reaction after taking place, even though the products are now different from the reactants, the mass has stayed the same. It is still 300.23 grams. So this is an example again that illustrates the law of conservation of mass, that again mass cannot be created and it cannot be destroyed. It stays constant over time. Now let's look at an example question that you can do on your own. The question says, according to the reaction below, you react 10 grams of ammonia, or NH3, and 15 grams of water to produce one product, NH4OH. Our question asks us how many grams of NH4OH will be produced. Now pause the video and take about 30 seconds to a minute to predict how many grams of NH4OH will be produced. So once again, our question says that we react 10 grams of ammonia and 15 grams of water. So that means that the total mass of our reactants is 25 grams. And again, according to the law of conservation of mass, we said that the mass of the products has to equal the mass of the reactants. So, since we reacted 25 grams, our product will also have a mass of 25 grams. This restates the law of conservation of mass by saying once again that the conservation of mass will be true. The mass of our products and reactants has to be equal.